Hello again, everybody. In this video, we're going to be continuing our look at the 2009 Friar. In fact, we're going to be finishing things off. We're going to be looking at question number 4 on the 2009 Friar paper. So let's take a look. The additions shown below, representing 2 plus 22 plus 222 plus 2,222 plus and so on, has 101 rows, and the last term consists of 101 twos. Okay, so we're looking at a really big sum. So A part, determine the value of the ones digit A. Okay, so he should just be the ones digit of the sum of this column of twos. How many twos are there? There's going to be 101 twos. And we'll carry something over into the next column. I assume this B is here because we're going to be adding, and we're going to be figuring that out. But in this, we just need the units digit, so that's the ones digit A of the product of 101 twos, or the sum of 101 twos. So let's take a look. Right. So we've detailed exactly how addition goes. You know, we start with the rightmost column, we add up all those numbers, and we carry over anything greater than 10 into the next column, and then we would add that up, and then we keep moving from right to left as we add. So to figure out A, we need the units digit of this total sum. Well, that's just going to be the units digit of the sum of the leftmost column. We haven't carried anything over because it's the first column we're working with. So just 101 twos, we add those up, we get 202. So A is the units digit, and what's left to carry over is the 20, the 20 from 202. So I mentioned the carryover because I imagine we're probably going to have to figure it out. I already mentioned that I think we're going to figure out B in the next part. Okay. So that's part A. B part, determine the value of the tens digit B and the value of the hundreds digit C. Okay, so we'll just continue on with our summation. Right, we don't have to even, we don't need to miss a beat. We can continue on as though we're still doing the same part of the problem. We'll just highlight the A equals 2. So the number of 2's in the column, we're going to adding up 102's. and 20, which is what we carried over into this column. So that's going to be 200 plus 20, 220, 0, so just 220. So B equals 0, we'll highlight him and continue on. And we carry the 22. Okay, now we want C. That's the units digit of the sum. Well, how many 2's are in there in that column? Well, the first column had 101. The second column we dropped down, so we only have 100 2's left. Then now we're going to have 99 2's. So 99 2's we're adding up, and then we also have to add up what we carried over, which is 22. Okay, so that's 198 plus 22. That's going to be 220. Again, I wonder if we keep getting 220. I don't think so. I think we'll have to... Yeah, because the next one will be 196, and 22 plus 196 is definitely not 220. It's 21 something. Okay. So once again, we just take the units digit of our sum. We'll add 0, so C equals 0. So we carry the 22. So now we have A, B, and C. We've done parts A and B of the question. Let's look at C part. This should probably be a little harder because, frankly, we haven't run into much of a challenge yet. C. Determine the middle digit of the sum. Okay. So the middle digit of the sum. Well, we know the bottom row consists of 101 2's. So we have at least 101 digits in our total sum, even if a bunch of them are 0, like C and B are. But maybe we have more. And they're asking for middle digits, so I'm suspecting it's going to be an odd number. Because I don't think it'd be a trick question of, oh, there's 102 digits, what's the middle one? You can't have it. So there's probably either 101 digits in our final answer or 103. You can't really get 105, I don't think. I don't think there's enough 2's. But the first thing we need to do is figure out which one is the middle digit. Okay? Not which is the middle, where is the middle? So if we figured out how many digits are in the final answer, we would take the middle digit there. As a little minor check, when we find out how many digits are in the final answer, we should get an odd number. If we get an even number, we can't really have a middle digit in the final answer. We'd have 2 middle digits, which would not go well. So how many digits are in this final answer? Okay. We know that there's at least 100. Sorry, not at least 100, at least 101. So, we have a single 2 in this leftmost column. It's just a 2. So we need to carry over from here. We need to carry over at least an 8. 8 or more. So we need to get it up to add up to at least 80. Now that's not the weirdest thing we've seen so far. We've seen a sum of columns with the carryover add up to 220. So it's not completely out of the realm of possibility. Now, these two add up to 4, so our carryover is going to have to do a lot of work. I mean, here, carryover of 8, that can happen in a regular addition. But a carryover of... So it's going to have to be at least 76. Alright, something's starting to get more fishy. Carryover of 8, sure. Maybe in the weird scenario. But we need to get a carryover of 76 to make that carryover of 8 happen. Otherwise, our numbers here are going to be, we'll carry over like a 7, or more likely something like a 1 or a 2, and we'll get 101 digits in total. Right? So to get more than 101 digits, 102 or more likely 103, we would need to get at least 8 as our carryover from our previous column. So what does that tell us? Well, the second to the leftmost column has to add up to at least 80. There's only 4 numbers there, so the carryover from the third column's got to be at least 76. And 76 seems way too big of a carryover. So I would guess there's probably a limit to how much we can carry over. Sorry, this seems too big, not too big. Alright, so we've seen 20 be carried over, we've seen 22 be carried over, and that's because in total the columns added up to, 202, 220, 220. The next one will be 21 something. So it looks like the 20s are about as good as we can get, so how about we shoot for showing that we can't get over 30? So we're going to try and induct on the columns. That means that we assume something is true for the column just to the right of the column we're talking about, and we use that to show that it doesn't work for the column we are talking about. So the first column So now suppose that we're at an arbitrary column. Oops, not of 30, we want something less than 30. So we want this sum, including the carryover x added to it, to be less than 300. That'll give us a carryover of less than 30. Well, how many 2's are there? Well, in the first column, there were 101 2's. In the second column from the right, there were 100 2's. So there's going to be 102 minus k plus 1. That's a little formula. I mean, I got that rather quickly. It might take you a little while longer to figure out the formula for the number of 2's in terms of k, but that's okay. Eventually, you can get there. So that plus that plus x. So we're looking at 204 minus 2k minus 2 plus x. So that's 202 minus 2k plus x. Well, k is positive. So that's less than 202 plus x, which is less than 202 plus 30, because x is less than 30. So why are we trying to do this? Why are we trying to show there was a limit to the carryover? So that we could show that there could never be a carryover of 76. That seemed way too high. Why did we want to find a carryover of 76? Because it might mean that our final answer had more than 101 digits. But we showed that can't be true, so we know our final answer only has 101 digits. Okay. Now, all of that was just to figure out what is the middle digit. So we now know where the middle digit is. And just like when we figured out A, B, and C, we can know the middle digit right, the 50th column from the right. Right, and we have a formula for the number of 2's, or the sum, from the columns as they are numbered from the right. So we're looking at the 51st column. It's going to be 51 2's. We could either use our formula, or we just know that the middle column is going to have the same number of 2's in it, no matter, and we don't need to specify 51st column from the left or right. It's in the very middle. We'll call that carryover X. So we get the ones digit of 51 times 2 plus X. So that's 102 plus X. And we know X is going to be no more than 30. Okay, so this is going to be no more than 132 over here, but that's still a wide range of values. We could have X be 29, and then we get a ones digit. We could be 28. We could get a 0, or a 27. We could get a 9 here. So we need to figure this out a bit more. So we have the carryover from the sum. We're summing up the 50th column plus y, where y now, I know it looks like I'm just repeating myself, and we're just going to keep going back, carrying over and carrying over, but because we know carryovers can be no greater than 30, we'll only have to do this at most one more time before we limit what X can ultimately be. So that's 52 times 2 plus y, so that's 104, right? 104 plus y. Okay. So our carryover is something like 10 or 11 or 12. It can't be 30 because y has to be less than 30. Okay. So now we know we're adding. We know X is going to be 10 or 11 or 12. So that definitely narrows it down. Before, it could be anything from 0 up to 30. And that really impacted what the final digit could be. But now we only have 3 cases. So going further back and examining previous columns and seeing what the carryover is, knowing that the carryover is limited and so its effect will diminish over time, we can sort of really clamp down on what the final answer should be. So I'm guessing after this we might have just one answer or maybe 2 possible answers, and we'll have to figure something else out. So it's carryover from, I'm not even going to bother writing out the column stuff anymore. So that's the carryover from 48th column. Okay, so what's that? Well, that's 102 minus 49, which is 53, and hopefully some of you out there knew that. So 106, oops, not 16, 106 plus Z. Okay. But that really limits, I mean, Y is going to be the first two digits of this sum. Now, Z can be, he can be anything. He can't be 30, so he can be 20-something, he can be 10-something, he can be 0-something. And that means that this is going to be, 10-something or 11-something or 12-something. So Y is equal to 10, 11, or 12. But then at that point, a 10, 11, or a 12, that's just going to give a carryover of X equals to 11. So that's either going to be 114, 115, or 116. So our carryover for X is exactly 11. And that allows us to complete the calculation, figure out exactly what the middle digit is, and we get a middle digit of 3. So that took a lot out of us. Two-part question. They asked us for the middle digit of the sum. First of all, we needed to figure out where the middle digit was. Was it the 51st column? Was it the 53rd column? The 52nd column? So we had to figure out how many digits are in the final answer in total. And because of that, that led us to realize that there's limits as to how much can be carried over from column to column in our sum. And because of that work, we were really easily able to show that once we knew it was the 51st column, going back just a couple columns and knowing that there was a limit on what could be carried over, that eventually was able to give us a final answer. So it was actually kind of sneaky. In trying to determine the total number of digits, we were able to develop a very simple upper bound on what the carryover was, and that really factored in later. I think that's a very well-designed question. And thus concludes the 2009 Friar. So it's quite an excellent question to end off on. I really like that. We're feeling good. Maybe we should just jump straight into another contest. But I'll let you guys decide that. Don't forget to like or subscribe as you so desire. But either way, hopefully you'll join me for the next Friar or maybe the 2009 Galois. Who knows? I'll see you guys in the next video.